There we go. Okay. So there are objectives and practice problems. We're going to find the exact value of an inverse sine function and find the approximate value of an inverse sine function. And then we're going to do the same thing with cosine and tangent. And then the whole reason we're doing this is so we can solve some trigonometric equations. So I'm gonna talk about inverse functions in general for just a minute here. Okay, so this is not related to inverse trig functions, but it's related to inverse functions in general. So I'm going to talk about the function y equals x squared, or we can say f of x equals x squared, and we know that f of x is the same thing as y. So just to kind of make sure we're totally clear on this, if I make a little t square, and here's my x, and here's my y, this is the same thing as f of x. Y is f of x, which means that when I take an x value and I put it into the function here, I'm going to square it, and I'm going to get a y value. So if I put in 0 for x, well, 0 squared is 0. If I put in 1 for x, well, 1 squared is 1. If I put in 2 for x, well, 2 squared is 4. If I did -1, I would get +1. If I did -2, I get +4. Everybody okay with that? Yeah, this is kind of a very basic function. And I could take that and I could graph it. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And if I was to graph it, I would go, well, I have the point 0, 0. So that I know is right there at the origin. The point 1, 1. The point 2, 4. Then -1, 1. -2, 4. And I could make that into a nice, that's really a pretty ugly parabola, but it'll do. It'll do. I can make that into a parabola. So everybody okay with that? Yes? Katie, you have a question? Or you just said that was a thumbs up? Okay, good. Okay. All right. So an inverse function, this is where you have to listen carefully. An inverse function, all it means is that I am switching the x's and the y's. So if I have the function y equals x squared, the inverse of that function is going to be x equals y squared. All I did was switch the, it looks like a G, let's change it. All I did was switch the x's and the y's. That's all I did. An inverse function just says flip the x's and the y's. That's all it says. This right here, x equals y squared, is called the implicit inverse. And frequently what we want is we want an explicit inverse, which means solving for y. I want y all by itself so that it's just like a typical function. I want the inverse function with y all by itself. So if I know that my implicit is y squared equals x, then to get a y all by itself, I would take the square root of both sides, and I would have y equals plus or minus the square root of x. This is explicit. Everybody with me still? Yes? Okay, but we got a little problem with this relation right here. Because if I am going to graph that, I have plus or minus the square root of x. Well, do you remember that the square root of x the function looks kind of like that. This is the function square root of x. Does everybody remember that? Are we okay with that? Well, it's plus or minus the square root of x. So minus square root of x, I have to go down here. This is negative square root of x. And the problem that I have now is that this is not a function. It doesn't pass the vertical line test. Remember the vertical line test for a function? I'm seeing yeses, yeah? Right. Plus or minus square root of x fails the vertical line test. I hit my function, I hit my relation twice. The reason we spend so much time talking about functions is because functions are very special. A function says that for every x, there is one and only one y. So here's a function I just made up. I'm calling that function f. And you can pick any x you want, and whatever x you pick, I am only going to have one y. It passes the vertical line test. Every place I have an x, I am only going to have one y. And that's really important if I'm modeling something in the natural world, in the real world, and I want to be able to make some predictions. I want to be able to say, well, if I use this input value, I'm going to get that output value. I don't want to have to choose which output value I'm going to get. I don't want to have a relation that looks like this and say, okay, well, if I put in x, what value do I get? Well, it's either that one right here or this one right here. I don't know which one it is because it's not a function. Right? I really want it to be a function. Am I making sense here? You following what I'm saying here? I'm just trying to give you some background on what's going to become important here. So in order to find an inverse function, as opposed to an inverse, this is an explicit relation, a relation just saying, well, I have a relationship between the x's and the y's, but it's not necessarily a function relationship. In order to get an inverse function, what I need to do is I need to look at my original function and I need to restrict the domain. So let's look at our function here, x squared. If I say, okay, I would like an inverse function out of this, but I am not going to pay any attention to this piece here. I am only paying attention to where x is greater than or equal to 0. Well, now when I take the square root, this negative piece is gone. So I only have this top piece here. All of this bottom part here goes away. And all I have is the top part. So now I do have a function. I have just positive square root of x. And that does pass the vertical line test. That is a function. Okay, so let me just pause there and see if there's a question. I'm kind of giving you this background so you can kind of maybe get your head around what we're going to do in just a minute. It's not like I'm going to test you on, this whole diatribe that I just ran, this whole monologue that I just did, but I want you to understand the difference between an inverse function, which sometimes requires us to restrict the domain, and an inverse relation, which, it just isn't a function, right? Doesn't give me that prediction ability. So are we like 50% on this? 50%? That's all I'm asking for is 50% on this. We're okay? We're so-so. All right. Let's kind of go on and see if it begins to make sense. So I want to talk about this in relationship to the trigonometric functions, and I'm going to start with the sine function. So remember, with the sine function, first of all, there's no such thing as sin. That's only in religion class, right? In math class, this has to have an argument, and the argument of a trigonometric function is an angle. The argument is an angle, and then for an answer, we get a number. Okay, so this is equivalent to the x. That's our input value. And this is equivalent to the y. That's our output value. I want to stop right there. Does that make sense to everybody? Right. Yeah, Jordan, please.
Could you repeat that one more time, please?
Yes. So every function has to have an argument. Are you good with that?
Yes.
And with a trigonometric function, the argument, the input value is an angle, which we call theta. So for example, I can say, what is sine pi over 6? The input value I'm giving is the angle, a pi over 6 angle in radians, right? And then the output, well, sine pi over 6, that is going to be a number 1/2. Okay, so it's like, and then if I was graphing this, so I would have here would be pi, and over here would be pi over 2, and let's just say right over here would be pi over 6. I would graph this by saying, so if this was 1, then this is 1, and this is 1/2. I'd say, okay, I have an x value of pi over 6, my input value, a y value of 1/2. So I would have put a point on the graph right there. This is my x, that's my y. A y, not an x. That better?
Yes, thank you.
Everybody good with that? We're good. Thanks for asking the question. That's good. Okay. So if I want an inverse trigonometric function, I'm going to switch the x's and the y's. I'm going to say the argument of an inverse trigonometric function is a number, and the answer is an angle. All I'm doing is switching the x's and the y's. That's all I'm doing, is taking the x's and the y's and switching them one for the other. So it's important to kind of take a note of the notation of an inverse trigonometric function, because the way we indicate we want an inverse function is we go like sine, and then we have a little -1, kind of like an exponent. Now that -1 is right on the sign, so I would write like sine -1. We'll go over this in an example, but radical 3/2. So I'm saying I want the inverse sine function. My input value is radical 3/2, and I will tell you right now that our output value is an angle pi over 3. We'll find out how to get there. But the input value is a number, the output is an angle, and we indicate that's an inverse by putting this -1 there. Don't get confused. This sine -1 is not 1 over sine. I know we're used to the -1, a negative exponent, meaning that it's 1 over that value. That is not the case. The notation that mathematicians have agreed on is that trigonometric function to the -1 means that you're looking for the inverse function, not the reciprocal function. There's a difference between the inverse and the reciprocal. All right, we okay with that? All right, so let's see if we can't look at, so I want to look at one more thing here. Yeah, before we get to a problem, we're going to have to look at one more issue with inverse trigonometric functions. So I'm going to not do Kirk Gibson anymore, but I'm going to get Desmos out here. And I'm going to graph sine x. So there's a graph of the sine function that should look very familiar to everybody, right? Graph of the sine function. And you know what? Let's just leave it like that. Okay, there's a graph of the sine function. So actually, let's do it like this. I'm going to go y equals sine x. It's the same thing. But now I am, one more thing. It's a function because it passes the vertical line test. For every x value, one and only one y value. Right? I can have the same y value, but every individual x value only has one y value. Now let's look at the inverse function of sine. So I'm going to switch the x's and y's, and I'm going to say x equals sine y. All I did was switch my x's and y's. Is that a function? Is the blue a function? The blue is not a function. The blue does not pass the vertical line test. If I pick an x, like right here, well, I have this y here, or maybe it's that y there, or maybe it's this y way up here, or maybe it's this y down here, or maybe it's this y down. There's an infinite number of y's when I pick an x. It's not a function. Bummer, right? I have to make it into a function. And in order to make it into a function, I am going to restrict the domain of the sine function to negative pi over 2, pi over 2. So let's take a look at what that means. So it's telling me right here, and you'll find this in the slides and in the book, it's saying if I want to find an inverse function, I have to restrict my x's to negative pi over 2, pi over 2. And this is the portion of the sine function that I am allowed to use. So let's use an example here. So we're going to find the exact value of an inverse sine function. Okay. And we're going to use sine minus 1 radical 3 over 2. So let's actually just do that on a separate blank page without all that other stuff there. And I want to find inverse sine, so sine minus 1. My input value is a number, and my answer is going to be an angle. I need to find out what angle has a sine value of radical 3 over 2. Well, I'm going to do that like this. And now everybody's allowed to use this in any time, right? I'm going to go to my unit circle. You all have this. This is my unit circle clock picture, right? You can use this. You're allowed to use this on tests, on homework. Any time you want to use this, you're welcome to use it. And so I need to find, no, I don't. What are you talking about there? Okay. I need to find out what angle has a sine value of radical 3 over 2. Okay, so I'm looking at my units. Sine is the y value, right? Sine is the y value. So I'll look over here. No, that's a half. That doesn't work. And this is radical 2 over 2. That doesn't work. Oh, my sine value right over here is radical 3 over 2. So a pi over 3 angle has a sine value of radical 3 over 2. Let's just keep going around, see what else we find. Right? So, uh-oh. I got radical 3 over 2 here also. So 2 pi over 3 has a sine value of radical 3 over 2. Remember, I'm trying to find inverse sine radical 3 over 2. That's my sine value. I'm trying to find the angle theta that covers, and I got a problem because I have two angles, pi over 3 and 2 pi over 3. What am I going to do? How am I going to decide? Well, the way I'm going to decide is I'm going to remember that we can only do this where sine theta for theta less than or equal to pi over 2, greater than or equal to negative pi over 2. We restricted the domain of my sine theta. So my answer for the inverse has to be between pi over 2 and negative pi over 2. This is negative pi over 2. This is positive pi over 2 right here. So my answer has to be between those two values. Well, I'm sorry, but if I want to go between those two values, I have to go from negative pi over 2, which is my lower number, and here's pi over 2 over here. Any answer for inverse sine has to be between negative pi over 2 and positive pi over 2. All this area over here on this side of the unit circle, this is called forbidden territory. You are not allowed to go there. You are not allowed to go into forbidden territory if you are looking for an inverse sine angle. And that really shouldn't be a problem because all the values of sine we know are between the domain of the sine function is -1 to 1. And all of those values fall right here from +1 down here to -1. So I'll have every possible value of sine right here. So anything that I would put in as an input value here, I'll be able to find it between negative pi over 2 and pi over 2. Okay. Questions? I just ran a lot at you. I'm glad I recorded it so you can listen to it again. Yes, Esme.
Could you repeat what you said? So you said forbidden territory if looking for inverse. What was it?
Yes. So if I'm so remember, I have an input value for the inverse sine is a number, right? And so that means I need to find a value, an angle that is going to have a sine value of radical 3 over 2. Are you okay with that? Okay. So I'm looking at for all my sines, where do I have a sine that's radical 3 over 2? And I see I got one over here. And I have one over here. And I have to have a decision as to which one to use. And mathematicians around the world have agreed that the angle that you use is the angle that is between negative pi over 2 and pi over 2. And this angle over here, 2 pi over 3, is not between negative pi over 2 and pi over 2. It is outside of that. So if I was to make like a number line, let's just kind of look at here. If I was to make a number line, and here was 0, and let's call here is pi over 2, and over here is negative pi over 2. You still with me? Okay. Well, 2 pi over 3 is out here. It's past pi over 2. It's not between these two. So I can't use that one. But pi over 3, that's in here. I'm allowed to use that one. So looking at it as part of the unit circle, come on. What's wrong? Go away. Looking at it as part of the unit circle, I like to look at it as this half of the unit circle. Okay, that's the only place that I can find an angle for an inverse sine function. This half over here, forbidden territory, can't go there. Bad men, bad robbers, orcs, you know, evil things, they're over on that side over there. We don't want that side. Only this side. This side has all the angels and all the good people and all the NDA students. That's the good side. Okay, pretty clear? Kind of. Let's look at another example. So no, I don't want to save that. I will open it up again. So we just did that one. Well, I want to find inverse sine negative radical 2 over 2. Okay, so I am looking for an angle that has a sine value of negative radical 2 over 2. Let's go back to my unit circle. Okay, let's call it up again. Here it is. Okay, so I'm looking for negative radical 2 over 2. I'm going to look at the whole unit circle, see if I can find negative radical 2 over 2. So no, these are all positive sine values, and these are all positive sine values. And here, I found one right here that is negative radical 2 over 2. Let's see, are there any more? Yeah, here's another one that's negative radical 2 over 2. So I have a 5 pi over 4 angle, and I have a 7 pi over 4 angle. And both of those have a sine value of negative radical 2 over 2. So remember, I'm looking for inverse sine, negative radical 2 over 2. And well, I can immediately rule out this 5 pi over 4 angle, right? Because that's over here in forbidden territory. I'm not allowed to go there, am I? Not allowed to go to forbidden territory. So is my answer 7 pi over 4? No, my answer is not 7 pi over 4. And why is my answer not 7 pi over 4? My answer is not 7 pi over 4 because, again, if I kind of look at it here as a number line, and here's pi over 2, and here's negative pi over 2. Wow, 7 pi over 4, man, that's like way over here. That's not between negative pi over 2 and pi over 2. I can't use that one. So now I'm thinking, wow, man, that really is a bummer, because I only see those two places where it's negative radical 2 over 2. But remember, what I'm doing is I'm going from negative pi over 2 to positive pi over 2. So I can get, if this is my initial side right here, I can get to this angle right here. I can get to the angle that is coterminal with 7 pi over 4 by going negative pi over 4. Negative pi over 4, well, that's like right in here. I'm allowed to use that because that is between negative pi over 2 and positive pi over 2. So it gets a little bit tricky, but I'm still on the right side of the unit circle. I can't go to 7 pi over 4 because to get to 7 pi over 4, I would have to go in this direction and cross through forbidden territory, and I would get eaten up by the orcs. I'm not allowed to do that. That's how I would get to 7 pi over 4. I can't do that. I can't go into forbidden territory. The way I can get to this angle right here is by going negative pi over 4. That's how I can get to this angle. So inverse sine of negative radical 2 over 2, negative pi over 4. This is our number. This is our angle. All right, how are we feeling about that? We're feeling 50-50. Okay, so 1, I'm sorry, totally lost. 2, maybe I'm kind of getting it. 3, oh yeah, this is making total sense. 1, 2s, or 3s. Got some 1s, some 3s, some 2s. Okay, good, good. So let me just take a look here. I think what we will do is we will start on Thursday with this problem. I think this was actually a pretty good recording. So I'm gonna put it on YouTube. I'll email it out to everybody if you want to listen to it again. I would say try some of the practice problems. Give it a try. Use your unit circle. Your unit circle is very valuable in this kind of work. And yeah, that's what I think we should do. Does that sound okay? Yes. Don't forget your test is due, right? On Friday, is that right? Did I get that right? Test due Friday? Okay. If you have any questions, ask me questions. I'm happy to answer questions. And 1, it stinks. 2, it was okay. 3, I couldn't believe how fantastic it was on Kirk Gibson. Okay, so everybody that didn't hold up a 3, you get Fs. Everybody else gets A's. That's the way it goes. All right. All right. We'll see you later. Goodbye. Have a nice lunch.
Thank you, Mr. Jacob.
You're welcome. You're welcome. Give me a second here.